In our increasingly digital world, the convergence of ethical hacking and generative AI technologies has become a crucial frontier in the realm of cybersecurity. As technology enhances, so do the methods employed by hackers, making it essential for ethical hackers to stay one step ahead. This course, part of a comprehensive learning journey, introduces you to the exciting world of ethical hacking and generative AI technologies. In this course, I'll dive into the evolving cybersecurity landscape, explore the techniques used by both malicious and ethical hackers, and explore how generative AI can be leveraged for both offensive and defensive purposes. By the end of this course, you'll be equipped with a solid foundation in ethical hacking and generative AI, enabling you to understand the complex dynamics between security and innovation in the digital age. This video provides an overview of generative AI and prompt engineering. Generative AI, which includes generative adversarial networks or GANs, is a branch of artificial intelligence focusing on generating new data by learning patterns from existing data. Generative AI involves two main components: a generator and a discriminator. The generator generates synthesized data samples, which may be images, audio, or text. Meanwhile, the discriminator tries to distinguish between real and synthetic data. The generator and discriminator work together in a competitive manner, improving over time to produce more convincing and realistic results. Generative AI models learn from a large dataset to understand the underlying patterns, structures, and statistical properties of the data. Once trained, the generator can create new data that resembles the original dataset, expanding the range of available samples. Prompt engineering, in the context of AI, refers to the process of designing and structuring prompts that are given to a language model in order to guide its responses and improve its output. It's a form of human-machine interaction that helps to better steer the AI's response by carefully crafting the input. This may involve specifying the format, the tone, or particular details desired in the response. The generator in a generative AI model is often prompted with input data to generate synthetic results, and therefore, the concept of prompt engineering can be applied in tuning these models to produce more desired outputs. There are several applications of generative AI in ethical hacking. There's adversarial data generation, data augmentation, mimicking attacker behavior, password cracking, improving cybersecurity defenses, testing and validation, and red teaming exercises. Okay, so let's go over these in a little bit more detail. First, adversarial data generation. Generative AI can create synthetic adversarial examples that exploit vulnerabilities in machine learning models. These examples are crafted in an attempt to deceive the model, exposing weaknesses and helping improve the model's robustness against attacks. Generative AI can augment existing datasets by generating additional realistic samples. This can enhance the performance of machine learning models, making them more robust and less prone to overfitting. Generative AI can simulate attacker behavior by generating realistic network traffic, including various types of attacks. This allows ethical hackers to evaluate the security of systems and identify potential vulnerabilities. And of course, password cracking. Generative AI can be used to generate plausible password candidates based on patterns and structures observed in existing passwords. This can assist ethical hackers in password cracking attempts and identifying weak password practices. By leveraging generative AI, ethical hackers can identify and address weaknesses in cybersecurity defenses. The generated synthetic data and adversarial examples can help security teams improve intrusion detection systems, anomaly detection algorithms, and other defense mechanisms. Generative AI is also a valuable tool for evaluating the robustness and effectiveness of security systems. By generating diverse attack scenarios and testing them against defenses, ethical hackers can identify vulnerabilities and enhance the security posture of the targeted systems. And one last example, red teaming exercises. Generative AI enables ethical hackers to mimic real-world attack scenarios more accurately. By generating synthetic data and simulating attack patterns, red teaming exercises can better simulate the strategies and techniques used by actual malicious actors. With respect to generative AI and prompt engineering, there are privacy implications. The use of generative AI in ethical hacking scenarios raises concerns regarding privacy. Generating synthetic data that resembles real individuals' information may pose ethical dilemmas, requiring careful consideration and adherence to privacy regulations. And finally, there are ethical considerations. As with any AI application, ethical considerations are crucial when employing generative AI in ethical hacking. It's essential to ensure responsible use, protect individuals' privacy, and obtain proper consent and legal authorization when utilizing generative AI techniques for ethical hacking purposes. This video explores the importance of ethical hacking, particularly in the context of advancements in generative AI technologies. Ethical hacking, also known as penetration testing, involves intentionally but legally exploiting vulnerabilities in computer systems, networks, or software applications. The goal is to identify and address security weaknesses. Ethical hackers, also called security researchers or pen testers, use their skills and knowledge to help organizations identify potential vulnerabilities and enhance their cybersecurity defenses. Ethical hacking is more important than ever with the advent of generative AI. This is due to a number of factors, including vulnerabilities in AI systems, the need to protect sensitive data, adversarial machine learning, the need to secure autonomous systems, and compliance and regulations that have been developed to safeguard sensitive information. Let's explore the details behind these factors. First, vulnerabilities in AI systems. AI systems are totally reliant on training data. This can amplify existing biases if the data is skewed or unrepresentative, leading to potentially discriminatory outcomes. There's also adversarial attacks. Intentional manipulation of input data can deceive AI systems, causing them to produce incorrect results, posing a major threat to security-critical applications. Then there's a lack of robustness. AI systems may perform poorly on unseen data, being sensitive to minor input changes and unable to handle unfamiliar scenarios, which could be exploited by attackers or result in unintended real-world consequences. And of course, there are privacy concerns. The absence of proper privacy safeguards in AI systems, which often process large volumes of personal data, can lead to privacy breaches, unauthorized access to sensitive data, or inadvertent disclosure of private information. Next, explainability and transparency. So what do I mean here? AI models with unclear decision-making processes cause distrust and difficulties in identifying and mitigating biases or addressing accountability concerns. And there are also systemic vulnerabilities. So traditional cybersecurity threats can potentially exploit AI systems themselves, leading to unauthorized access, data breaches, or malicious manipulation of system behavior. So another reason why ethical hacking is so important is due to the need to protect sensitive data. Generative AI technologies often process and generate large amounts of sensitive data, including personal information or proprietary business data. Ethical hacking helps organizations identify potential vulnerabilities that could expose this data to unauthorized access, theft, or misuse. By proactively addressing these vulnerabilities, ethical hackers contribute to safeguarding the privacy and security of sensitive information. Then there's adversarial machine learning. Adversarial attacks involve manipulating or tricking AI systems by providing inputs specifically crafted to deceive the algorithms. Ethical hackers can leverage their expertise to develop and test defenses against such attacks. By understanding the techniques used by malicious actors, ethical hackers help improve the robustness and resilience of AI systems. Now, there are several different types of adversarial attacks, so let's explore some of these types of attacks. First, adversarial examples are perturbed input samples created by adding small, imperceptible modifications to the original data. Despite appearing similar to the original inputs, these perturbed examples can cause the model to produce incorrect predictions. Then there's evasion attacks. In evasion attacks, an adversary actively modifies input data during the testing or deployment phase to evade detection or achieve a specific outcome. For example, an attacker may modify spam emails to bypass a spam filter. And then there's poisoning attacks. In poisoning attacks, an attacker manipulates the training data by injecting malicious or carefully crafted samples. The goal is to corrupt the learning process and influence the model's behavior during inference. To mitigate adversarial attacks, researchers have developed various defense mechanisms, including adversarial training. This involves augmenting the training data with adversarial examples to improve the model's robustness. By exposing the model to carefully crafted adversarial inputs during training, it can learn to be more resilient against such attacks. Then there's defensive distillation. This technique involves training a secondary model on the outputs of the original model and using it as a defense mechanism. The distilled model is less susceptible to adversarial examples due to the smoothing effect of the intermediate prediction, input sanitization, and anomaly detection. Pre-processing techniques can be applied to input data to remove or neutralize potential adversarial perturbations. Anomaly detection methods can also be employed to identify inputs that deviate significantly from the expected distribution. And certified robustness. Methods such as interval-bound propagation and randomized smoothing aim to certify the robustness of a model by providing provable guarantees on its performance under adversarial attacks. There's also the need to secure autonomous systems. So generative AI technologies are increasingly being integrated into autonomous systems, including self-driving cars, drones, or industrial automation. Ethical hackers play a crucial role in identifying potential security flaws or vulnerabilities in these systems. By exposing weaknesses and providing recommendations for improvement, ethical hackers contribute to enhancing the safety and reliability of autonomous systems. Now, to address these concerns and secure autonomous systems, there are a number of steps that we can take. We can secure training data for generative AI models by implementing storage, encryption, and access controls and detecting and mitigating biases or adversarial examples. We can improve system resilience against adversarial attacks through techniques like adversarial training or robust optimization. We can validate and verify generative AI models via extensive testing, performance evaluation, and by using techniques like model explainability and interpretability. We can also implement real-time monitoring to identify anomalies and unexpected system behaviors using algorithms and behavior analysis. And we can design autonomous systems with robustness and fault tolerance by incorporating redundancy, error handling mechanisms, and fail-safe measures. Still, with securing autonomous systems, we can protect communication channels and data exchanges using secure protocols, encryption, and authentication mechanisms, regularly apply security updates and patches to the generative AI models, and stay informed about new security advancements. We can ensure the use of generative AI and that it aligns with ethical guidelines and prioritizes human safety and well-being. We can utilize ethical hackers to conduct penetration testing and security assessments of the generative AI components, and maintain compliance and regulations with standards related to data privacy, security, and safety in the context of generative AI and autonomous systems. So, with the increasing adoption of generative AI technologies, compliance and data protection regulations and cybersecurity standards in the context of generative AI becomes a crucial part of an organization's security posture. Ethical hackers can help organizations meet regulatory requirements by conducting security assessments, identifying gaps in compliance, and recommending appropriate security measures. Now, let's wrap this up with some important considerations regarding compliance in ethical hacking using generative AI. First, understand and adhere to the legal and regulatory frameworks governing ethical hacking. Secure proper consent and authorization before conducting ethical hacking activities using generative AI technologies. Sign and adhere to non-disclosure agreements to protect the confidentiality of sensitive information during ethical hacking. Respect intellectual property rights and avoid unauthorized use or replication of proprietary algorithms or materials. Handle data with the utmost care and comply with data protection regulations also ensuring secure storage and handling of data during ethical hacking activities. And stay updated on industry standards and best practices related to ethical hacking and generative AI, and adhere to these guidelines and code of ethics. This video explores the impact of generative AI on ethical hacking. Generative AI technologies present both challenges and opportunities in the field of ethical hacking. For challenges, there are advanced attack techniques, increased attack surface, adversarial attacks, and also has an impact on malware generation. Let's explore these points in more detail. Okay, so first, advanced attack techniques. Generative AI can produce deceptive, sophisticated attack vectors, such as convincing phishing emails or websites. The constant evolution of threats due to generative AI necessitates continual defense updates. Stealthy, evasion-focused attacks can be generated by AI models to bypass detection mechanisms. Generative AI enables the automation and scaling of attacks, overwhelming security systems with large volumes of malicious content. The lack of transparency and explainability in some generative AI models hinders defense strategy formulation. Also, the misuse of generative AI can result in potent cyber weapons, with availability in underground or open source platforms amplifying the threat. And the use of generative AI in hacking presents ethical dilemmas, such as potential privacy violations and misuse of personal data. Now, generative AI also supports increasing the attack surface. So what do I mean here? Generative AI automates vulnerability discovery, which can be exploited on a large scale by malicious actors. AI's interaction with complex system components expands the attack surface due to potential exploitation of weaknesses. AI integration with IoT devices broadens the attack surface as hackers target interconnected device vulnerabilities. Cloud environment vulnerabilities can be identified and exploited by generative AI, risking data breaches and service disruptions. Dependencies on third-party elements pose additional vulnerabilities that can be exploited with AI, potentially leading to unauthorized access. And the intersection of generative AI with emerging technologies and potential insider threats amplifies the attack surface and complexity of threat detection. Generative AI's vulnerability to adversarial attacks allows evasion of AI-based security measures, including image recognition and spam filters. The transferability of adversarial attacks allows successful breaches to be replicated across similar AI models, creating widespread vulnerabilities. Generative AI models' reliance on large volumes of training data can be exploited by adversarial attacks, leading to incorrect predictions or decisions. Stealthy adversarial attacks can subtly alter inputs to generate undetectable breaches that mimic legitimate data. The dynamic nature of adversarial attacks necessitates continuous adaptation from ethical hackers to protect against evolving threats. And generative AI's lack of transparency can complicate understanding adversarial techniques, while the potential for unintended harm raises legal and ethical considerations. Malware generation. Generative AI enables the creation of highly evasive, sophisticated malware variants, making detection and mitigation difficult. The use of generative AI to create polymorphic and constantly evolving malware poses challenges for accurate detection. Generative AI can automate the discovery and exploitation of zero-day exploits, increasing the success potential of attacks. Also, AI-created malware mimicking legitimate software increases the risk of inadvertent malware installation by users. And finally, the enhanced distribution and unpredictability of AI-generated malware, coupled with its ability to evade behavioral analysis, complicates effective mitigation. Now the opportunities. Generative AI helps by automating vulnerability assessment. It offers intelligent intrusion detection, can counteract adversarial attacks. It enhances security analytics, and has an impact on security testing and red teaming. Now let's explore these opportunities in more detail. Starting with automated vulnerability assessment. So generative AI technologies provide scalable and efficient automated vulnerability assessments, enabling quicker identification of vulnerabilities. Then there's the effect on training generative AI on historical data, and this leads to rapid detection of known vulnerabilities, helping prioritize critical security risks. AI models yield more accurate and consistent vulnerability assessments by reducing human biases and error. Generative AI can enhance coverage and vulnerability assessments by analyzing various systems, applications, and configurations. Continuous data analysis by generative AI can lead to early detection of emerging vulnerabilities, enabling proactive threat mitigation. Generative AI models adapt to changing security landscapes and update assessment techniques, enhancing its efficacy in dynamic environments. Generative AI technologies augment ethical hackers' capabilities, enabling a productive symbiosis between human expertise and AI automation. And integrating AI-powered vulnerability assessments into continuous monitoring systems allows for ongoing vulnerability detection and remediation. Now, the opportunity of intelligent intrusion detection. Generative AI technologies enhance threat detection by analyzing vast data and detecting complex patterns of normal and malicious behaviors. AI-powered intrusion detection systems provide real-time network traffic monitoring and alerts for suspicious activities. Generative AI models understand user, device, and system behavior, facilitating the detection of deviations that signify potential intrusions. Generative AI technologies consider contextual information for accurate intrusion detection while also identifying anomalous patterns for detection of unknown or zero-day attacks. AI-powered intrusion detection systems adaptively learn and improve detection capabilities over time by continuously analyzing new threats and attack techniques. And generative AI can streamline incident handling via integration with incident response workflows and support threat intelligence sharing among ethical hackers for improved cybersecurity posture. Generative AI enhances adversarial training and development of defense mechanisms, enabling AI models to better resist common attack techniques and identify adversarial behavior. The use of generative AI can result in more robust and explainable models that resist adversarial perturbations, providing insights into attack construction for effective defense strategy. AI-powered systems offer real-time monitoring to detect adversarial activities, triggering alerts for prompt response and mitigation. The ethical hacking community leverages generative AI for collaboration and knowledge sharing, collectively developing robust defense strategies against adversarial attacks. And generative AI facilitates continuous research, along with the reduction of false positives, which improves efficiency and allows ethical hackers to focus on genuine threats. With respect to enhanced security analytics, generative AI improves advanced threat detection by analyzing various data sources to identify potential security threats and sophisticated attacks. By learning normal behavior patterns, generative AI assists in anomaly detection and allows quick mitigation of potential security breaches. Leveraging generative AI for predictive analytics enables anticipation of security threats, providing early warnings and proactive risk mitigation. Generative AI's capability for pattern recognition helps it recognize attack trends, and by integrating contextual information into security analytics, generative AI enhances the accuracy and relevance of analysis. Now, security testing and red teaming. Generative AI technologies automate vulnerability assessment and simulate advanced exploits, enhancing efficiency and identifying complex vulnerabilities in security systems. By simulating adversarial scenarios and generating custom attack vectors, generative AI offers a tailored and realistic evaluation of system defenses. Integrating generative AI into CI/CD pipelines enables continuous security testing and early detection of vulnerabilities throughout the development lifecycle. And finally, generative AI's capabilities for predictive analysis, combined with collaborative learning within the ethical hacking community, allows proactive addressing of security risks and shared growth in defensive strategies. This video explores how generative AI is applied to hacking phases. The phases of hacking generally involve reconnaissance, scanning, gaining access, maintaining access, and covering tracks. While generative AI can potentially play a role in each of these phases, it's important to note that AI technology can be used for both defensive and offensive purposes. In this video, we'll explore a breakdown of how generative AI could be involved in each phase. So first, let's go over each phase. First, reconnaissance. Reconnaissance is the phase where an attacker gathers information about the target system or network. During scanning, Hackers actively probe the target network or system to identify potential entry points or vulnerabilities. Then there's gaining access. In this phase, hackers exploit the identified vulnerabilities to gain unauthorized access to the target system. Then there's maintaining access. Once hackers gain access to a system, they aim to maintain their control and establish a persistent presence. And finally, covering tracks. In this final phase, hackers aim to cover their tracks and remove any evidence of their activities to avoid detection and attribution. So let's explore how generative AI could be involved in each phase. First, generative AI can be used to enhance reconnaissance. As we discussed, during the reconnaissance phase of hacking, attackers gather intel about the target system or network. Generative AI can enhance reconnaissance in several ways. Generative AI facilitates automated data gathering, for example, from various platforms, aiding in the identification of potential targets and vulnerabilities. Through the analysis of vast data volumes, AI algorithms can identify patterns such as common usernames or passwords, highlighting possible weak spots within the target system. Generative AI, using natural language processing and generative models, can craft convincing phishing content to manipulate individuals into revealing sensitive data. Then there's targeted reconnaissance. AI algorithms can automate the identification of potential targets by analyzing organization-related data, focusing efforts on more promising entry points. And then there's data analysis and visualization. Generative AI helps in the analysis and visualization of reconnaissance data, unveiling hidden relationships or anomalies, providing valuable insights into the target's infrastructure or network. Now, with respect to the scanning phase, generative AI enables the development of automated tools for analyzing network configurations, scanning open ports, and identifying system weaknesses, thus streamlining the attacker's process of spotting exploitable areas. Generative AI aids in creating intelligent, specifically tailored payloads or malicious code, increasing the chances of successful exploitation and lowering detection likelihood. AI algorithms can develop scanning techniques that adapt based on system responses, enabling dynamic modification of scanning parameters to evade intrusion detection systems or firewalls. Generative AI assists in fingerprinting systems or identifying specific services running on a network, enabling attackers to exploit known weaknesses by identifying technology, software versions, or potential vulnerabilities. And covert channel detection. So generative AI can also detect covert channels or hidden communication paths within a system, enabling attackers to identify and leverage suspicious behaviors indicative of unauthorized access or data exfiltration. Now, for gaining access. Generative AI algorithms can enhance vulnerability detection within a system by identifying and prioritizing potential weaknesses, aiding in proactive security measures. Generative AI can create behavior-based intrusion detection systems that identify and flag deviations from normal user behavior or network activity, potentially preventing unauthorized access. Then there's adversarial machine learning. Leveraging generative AI techniques in adversarial machine learning enables security teams to simulate and analyze potential attack scenarios, thus strengthening system defenses. Generative AI can test password strength by generating potential passwords and identifying common patterns or weaknesses, supporting the enforcement of stronger password policies and user education. Generative AI also contributes to developing secure authentication systems using biometric data or multi-factor authentication, improving over time and making unauthorized access more challenging. Now, with respect to the maintaining access phase, generative AI algorithms can detect anomalies in system behavior or network traffic, aiding in the identification and response to ongoing attacks by noting deviations from established baselines. Generative AI can develop sophisticated evasion techniques by analyzing security logs or network traffic, emphasizing the need for continual security system updates to counter these evolving tactics. Then there's persistence mechanisms. Generative AI can help create adaptive, polymorphic malware and conceal malicious code within legitimate files, complicating detection and removal processes. Generative AI can automate privilege escalation within a compromised system by analyzing configurations, access control mechanisms, and user behaviors, identifying opportunities for gaining further system control. And AI can develop covert communication channels within a compromised system using methods such as hiding communication within innocuous network traffic or employing encryption methods hard to detect or analyze. And covering tracks. Generative AI can automate the manipulation of log files to remove or alter evidence of malicious activities, underscoring the need for robust log monitoring and integrity checks. Metadata alteration. Generative AI can alter metadata associated with files or network traffic to blend malicious activities with normal system behavior, complicating the task of security teams trying to identify these activities. Generative AI aids in developing sophisticated data exfiltration techniques that make detecting and tracing stolen data difficult, using methods such as analyzing network traffic patterns or encryption methods. Generative AI can develop anti-forensic techniques to obstruct investigations, including generating decoy files or using steganography to hide data, making it more challenging for investigators to uncover the attacker's activities. And generative AI can hide or modify malicious artifacts, such as malware or backdoors, allowing attackers to evade detection and complicate forensic analysis. This video explores the potential risks and benefits of using generative AI technologies in ethical hacking. Generative AI technologies have already started to revolutionize the field of ethical hacking. However, like most technological advancements, there are risks that must be managed alongside their potential benefits. Addressing risks ensures that the use of AI in ethical hacking is safe, effective, and beneficial. So, what types of risks can we expect to encounter? Well, one significant risk is over-reliance on AI. AI is an excellent tool for ethical hackers, but should not replace human expertise entirely. Over-reliance on AI could lead to a skills gap. Human intuition and expertise are crucial in interpreting AI's findings, for understanding complex security scenarios, and for making strategic decisions. If ethical hackers become too reliant on AI, their manual testing skills could wane, and their ability to think creatively could be compromised, thus reducing their overall effectiveness. User misinterpretation is a potential risk. AI systems are inherently complex, and the results they produce can sometimes be misinterpreted. For instance, a sophisticated AI system might identify a potential vulnerability, but a human analyst could misunderstand the context or severity, leading to overlooked threats or unnecessary responses to false positives, wasting valuable resources and potentially leaving the system vulnerable to attack. There's the potential for an algorithmic bias. As a machine learning technology, generative AI is only as good as the data it's trained on. If this data contains biases, the AI can inadvertently perpetuate and even amplify these biases, leading to unfair or discriminatory outcomes. This could manifest as biased security measures that overly target or neglect certain groups or behaviors. The next risk is unauthorized access. Ethical hackers often need to probe systems deeply to identify vulnerabilities. However, they must ensure that sensitive data is not inadvertently exposed or accessed during this process. Without proper safeguards, the use of AI in ethical hacking could potentially lead to unauthorized data access, which is a significant privacy risk. Then there's unintended harm. AI tools with their ability to execute operations at a high velocity and scale could inadvertently cause harm during penetration testing. Poorly calibrated AI, for example, could overload a system during a stress test, causing unintended downtime or even system damage. Then there are legal and regulatory challenges. The use of AI in ethical hacking might lead to legal and regulatory challenges. Challenges regarding the authorization of AI-driven tests, the extent of testing, and the handling of data may arise, especially when activities cross international borders. Clear policies and international standards are needed to ensure legal compliance. Then there are false positives and false negatives. So AI tools can potentially generate false positives, identifying benign activities as threats, causing unnecessary resource consumption and potential system disruptions. Conversely, they may also produce false negatives, failing to detect genuine vulnerabilities, thereby leaving the system exposed to potential breaches. There are ethical and privacy concerns. That's another risk. The use of generative AI in ethical hacking could raise ethical and privacy concerns due to the vast amounts of data collected and analyzed. Misuse or mismanagement of this data could infringe on individuals' privacy rights, potentially damaging public trust and leading to legal repercussions. Now, along with all the risks, there are several benefits. We'll start with scalability. Generative AI can process and analyze vast amounts of data at scale. This increased capability enhances the scope and thoroughness of security testing, going beyond the capacity of human analysts. AI can test numerous scenarios and data points simultaneously, identifying vulnerabilities more comprehensively. Another benefit is efficiency. AI can automate repetitive and time-consuming tasks, freeing up human resources for more complex tasks and strategic planning. This automation reduces human error and speeds up the overall process, leading to more efficient and effective ethical hacking operations. Another benefit is innovative detection. Generative AI's machine learning capabilities can identify new and unknown threats, enhancing the detection of zero-day vulnerabilities. This ability enables organizations to identify and address vulnerabilities before malicious actors have a chance to exploit them. Then there's continuous learning. Generative AI models are designed to learn from new data continuously. They can adapt and improve their capabilities over time, leading to progressively better threat detection and system resilience. This learning process ensures that ethical hacking methods evolve in tandem with emerging threats. Another benefit is generative AI's predictive capabilities. So, generative AI can forecast future attack trends based on current data. This predictive capability allows organizations to proactively develop defense strategies and implement safeguards before an attack occurs. There's also the benefit of resource optimization. By automating routine tasks, AI helps optimize resource allocation. This allows organizations to focus their human expertise where it's most needed and maximizes the overall effectiveness of their cybersecurity efforts. Then there's skill augmentation. AI tools can augment the capabilities of human ethical hackers. With AI's assistance, they can discover more complex vulnerabilities and enhance their problem-solving abilities. This enables the cybersecurity team to provide a robust and comprehensive defense against potential cyber threats. Now, to sum it all up, while the use of generative AI in ethical hacking presents potential risks, these can be managed through good practice, through continuous learning, and through robust policies and international cooperation. The benefits that AI brings to ethical hacking are significant, and with the right balance, AI could become one very powerful ally in cybersecurity. This video explores the ethical considerations and legal implications of using generative AI in ethical hacking. Organizations continue to rely more and more on technology, and so ethical hacking as a vital component of a robust cybersecurity posture is more important than ever. Ethical hackers have access to a range of powerful tools and technologies that leverage generative AI. These tools can significantly enhance the capabilities of ethical hackers by automating certain tasks, augmenting analysis capabilities, and supporting the identification and mitigation of vulnerabilities. However, the use of generative AI in ethical hacking also poses some very important ethical considerations and legal implications. Let's start by exploring some important ethical considerations. So one of the primary ethical considerations is informed consent. Using generative AI tools may involve accessing, manipulating, and analyzing sensitive data, which raises concerns about privacy. Ethical hackers must ensure they have explicit consent from relevant stakeholders before employing generative AI technologies to prevent unauthorized access and protect individuals' privacy. Generative AI provides an incredibly powerful tool for creating realistic simulations, for imitating human behavior, and for generating convincing content. Ethical hackers must exercise responsible use of AI to avoid malicious activities like deepfake creation, misinformation, or impersonation. Responsible use involves applying the technology to identify and rectify vulnerabilities, and not cause any harm to individuals or organizations. When using generative AI in ethical hacking, it's also crucial to maintain a high level of accountability and transparency. Ethical hackers should be prepared to justify the use of generative AI tools and provide clear explanations of their methodologies. Transparency builds trust with stakeholders and helps prevent any misuse or abuse of AI-generated content. So along with these ethical considerations are some significant legal implications. One such legal implication involves questions regarding intellectual property rights. The ownership and use of AI-generated content need to be clearly defined to avoid infringing copyrights or patents. Ethical hackers must ensure that their use of generative AI tools does not violate any intellectual property laws. Data protection carries significant legal implications. Generative AI often requires access to large datasets for training models. Ethical hackers must comply with data protection regulations and ensure that any data used for training or testing purposes is obtained lawfully and treated with utmost care. Anonymization and secure storage of data are paramount to safeguarding individuals' privacy and complying with legal requirements. There are also potential threats related to the application of generative AI to ethical hacking. For example, there is a significant potential for increased sophistication of malicious attacks. Generative AI enables the creation of highly realistic and convincing content, including fake documents, emails, and websites. In the hands of malicious actors, these AI-generated elements can be utilized to enhance the effectiveness of phishing, social engineering, or spear phishing attacks. By leveraging the power of generative AI, ethical hacking tools themselves can potentially be misused to deceive individuals or exploit system vulnerabilities. Another threat involves unintended consequences and false positives. AI models trained on large datasets can sometimes generate false or misleading results, which may lead to unnecessary alarms or misinterpretation of potential vulnerabilities. Relying solely on generative AI without appropriate human oversight and validation can introduce errors or inaccuracy in the identification and prioritization of real security threats. Now, these threats do exist, but we have to recognize at the same time that they are not inherent to generative AI itself, but rather these threats arise from the way generative AI is used. Ethical hackers and organizations must therefore exercise responsible and ethical practices when using AI tools to mitigate these potential threats and ensure the technology is used in a positive and secure manner. Now, some benefits that can be derived from the responsible use of generative AI in ethical hacking. First, efficient vulnerability detection. Generative AI tools can analyze large amounts of data and identify patterns and vulnerabilities at an unprecedented speed. By automating certain tasks, ethical hackers can streamline their workflow and efficiently detect potential weaknesses, reducing the time required for a manual analysis. Generative AI can also create realistic simulations of various attack scenarios, enabling ethical hackers to test their systems in a controlled environment. This capability allows for proactive defenses and preparation against emerging threats, thus enhancing the overall security posture. And finally, generative AI allows security teams to develop more robust defense mechanisms. By studying AI-generated attacks, organizations can gain valuable insights into related potential vulnerabilities, allowing them to strengthen their cybersecurity posture. This video explores the role of ethical hacker in today's digital landscape. As the world increasingly becomes digital, the demand for ethical hackers will continue to grow. Their role is crucial in maintaining the integrity of various systems and preventing the exploitation of potential vulnerabilities. Ethical hackers follow a code of conduct to operate within legal and moral boundaries, working to identify and address security weaknesses. Their work is especially significant as generative AI technologies rise in prominence and sophistication. Generative AI technologies have opened several opportunities across diverse sectors, yet They pose a new range of security risks and challenges, making ethical hacking more crucial than ever. Generative AI technologies can generate deep fakes, a form of synthetic media where a person in an existing image or video is replaced with someone else's likeness. They can also automate the generation of phishing emails or create malware that evolves and learns from its environment. Ethical hackers can help combat these risks by performing penetration tests, running vulnerability assessments, and even using AI themselves to predict and prevent attacks. They can simulate generative AI threats to anticipate the potential ways malicious hackers might exploit these technologies, thereby mitigating the risks before they can cause damage. There is also a need for continuous learning. As technology evolves, ethical hackers must be committed to continuous learning to stay up to date on the latest advancements and vulnerabilities. This necessarily means becoming familiar with generative AI technologies. This is important because not only do malicious hackers use generative AI, but they may also target AI-based applications and services themselves. Okay, so we've established that AI-based applications and services themselves can be a target. This raises an additional requirement for the role of ethical hacker. That is, understanding AI and machine learning. In order to properly test AI-based applications and services, ethical hackers need a deep understanding of AI and machine learning. It's crucial to understand how models are trained, how they can be manipulated, and what weaknesses they may have. There are potential pitfalls for ethical hackers to be aware of. Ethical hackers must be careful not to misuse AI technologies in the process of their work. The boundary between using AI for penetration testing and misuse can be thin, and it's crucial to avoid crossing it. Although the whole concept of ethical hacking is to operate within legal and ethical constraints, testing can also potentially involve delicate situations such as potential violations of privacy laws or terms of service if not conducted properly. So care must be exercised by ethical hackers to avoid any such legal issues. Then there are false positives. AI tools can generate false positives. Therefore, ethical hackers should be skilled enough to differentiate between false alarms and real threats. Now, in terms of ethical hacker skill set, ethical hackers necessarily need a broad skill set, including programming languages such as Python, C++, or JavaScript. They require a good understanding of operating systems and databases, knowledge of networking, and expertise in cybersecurity best practices. Ethical hackers need to understand AI, machine learning, and even data science has become a must-have skill for ethical hackers. Now, in terms of tool chains, ethical hackers use various penetration testing tools. There are traditional tools like Metasploit, Wireshark, and others, and there are AI-based cybersecurity tools such as Elastic Security for endpoint protection. There's tools like Cylance that use AI, algorithmic science, and machine learning to proactively detect advanced threats. Meanwhile, another tool, Deep Instinct, uses deep learning to predict, prevent, and analyze cyber threats in real time, and can also be used to protect against AI-based threats. These AI-based security tools have become an essential component of the ethical hackers toolchain due to the rise of increasingly sophisticated AI-based threats. They provide insights into potential system vulnerabilities, help in their proactive patching, and allow for the effective simulation of AI-based attacks, thereby enabling ethical hackers to build more robust defenses. These AI-driven cybersecurity tools not only detect patterns in vast amounts of data more efficiently than a human could, but, and this is important, they also learn from this data to continually improve their detection and prevention capabilities. This video explores the importance of maintaining high ethical standards when using powerful tools like generative AI in ethical hacking. The rapid advancement of generative AI has added a new dimension to the digital landscape. At the same time, ethical hacking continues to be a vital component of secure digital infrastructure and has evolved to include AI and AI-assisted attacks. With this convergence of technologies, the importance of maintaining high ethical standards related to their use becomes all the more critical. Let's consider the significance of such standards, the potential repercussions of ignoring them, and why this is particularly relevant now. Okay, so ethical hackers operate within defined moral and legal boundaries to find and fix system vulnerabilities before malicious actors can exploit them. The rise of generative AI technologies has significantly changed the required capabilities of both ethical hackers and malicious actors alike. Generative AI models can generate very realistic, convincing synthetic data, which can be used for a variety of tasks, including penetration testing, vulnerability assessments, and threat modeling. However, the power of these AI technologies requires strict ethical standards to be followed in order to prevent their misuse. High ethical standards in ethical hacking includes obtaining explicit access permissions, respecting privacy rights, and responsibly reporting discovered vulnerabilities. This necessarily means ensuring the ethical use of generative AI tools. Ethical hackers must be careful to ensure that their use of these powerful AI technologies doesn't cross the boundary into misuse or cause unintentional harm. Ignoring high standards in ethical hacking can lead to serious consequences. These include legal ramifications. Unethical hacking, even with good intentions, can lead to violations of privacy laws or terms of service, resulting in legal penalties. Misuse of hacking capabilities or AI technology can result in a loss of public trust, affecting not just the individual or organization involved, but also the broader perception of ethical hacking as a field. And the misuse of generative AI can lead to serious ethical breaches. For instance, creating deep fakes without consent can be harmful and damaging, infringing upon personal privacy and potentially enabling cybercrimes. Okay, so why are high ethics in ethical hacking so relevant now? Well, the use of generative AI in ethical hacking raises the need for strict ethical standards because the technology is incredibly powerful and in the wrong hands can be used to create realistic phishing emails, generate convincing deepfakes, and can also be used to create evolving malware that learns from its environment to avoid detection. In light of these potential threats, ethical hackers using generative AI must be diligent about their ethical obligations. They must understand the potential implications of the power of the AI tools they're using and take extra precautions to ensure they're used responsibly. For example, when using generative AI to create deepfakes for penetration testing, explicit consent must be obtained from those whose likenesses are being used. It's important to recognize that while AI can automate many tasks, it lacks a moral compass. What this means is that the role of ethical hacker is more important than ever since it serves as a critical human element in a position to ensure that ethical guidelines are upheld and that the technology is used in a way that respects legal norms and societal values. This video explores how organizations are preparing for generative AI-driven attacks. In the cybersecurity landscape, organizations are constantly challenged with the specter of new technological threats. Among these, the use of AI by hackers poses some unique and serious challenges. One emerging concern is the advent of generative AI, a powerful tool capable of generating human-like text, images, or sound, and its potential deployment for malicious purposes. That's why it's so important to understand how organizations are preparing for AI and generative AI-driven attacks, and what measures they're implementing to counteract these threats. AI is transforming several facets of modern life, and the field of cybersecurity is no exception. Malicious actors are exploiting these technologies to conduct more sophisticated cyber attacks. They leverage AI's data crunching abilities to analyze patterns, discover vulnerabilities, and automate tasks. Generative AI is used to craft persuasive phishing emails, deepfakes, or to mimic human behavior to bypass security protocols. For instance, AI-driven algorithms can help hackers carry out brute force attacks more efficiently by predicting the most probable password combinations. With generative AI, they can create highly realistic phishing emails uniquely tailored to each target, dramatically increasing the potential for a successful breach. In response to the emerging threats of AI and generative AI, organizations are investing heavily in AI-powered cybersecurity systems. These systems can also analyze patterns and detect anomalies in real time, offering a level of vigilance that is impossible for human operators. However, as the saying goes, an ounce of prevention is worth a pound of cure. In the context of cybersecurity, a crucial part of prevention includes continuous cybersecurity education for employees. At the same time, understand that training has expanded to cover the specific risks posed by AI and generative AI, such as recognizing AI-generated phishing emails or deepfakes. Many organizations are also employing AI-based defensive strategies to combat these AI-driven attacks. One such method is to use adversarial AI, which involves training systems to recognize and respond to AI-based attacks. By incorporating adversarial examples into their training data, AI models can become more robust and capable of identifying and mitigating AI-powered threats. Adversarial examples are inputs to machine learning models that an attacker has intentionally designed to cause the model to make a mistake. In essence, they are designed to trick the model into misclassifying or misinterpreting the data. Adversarial examples can be created by applying specific, small but carefully designed perturbations to real data such that a machine learning model misclassifies it. By learning to correctly handle adversarial examples, an AI can improve its ability to detect and fend off real-world attacks that aim to exploit the AI's weaknesses. Simultaneously, organizations are investing in AI-powered network monitoring tools. These solutions use machine learning to understand normal network behavior, and they can detect anomalies that may signal an attack. By automatically identifying and responding to these anomalies, organizations can prevent attacks or minimize their impact. Organizations must also acknowledge the inevitability of AI-driven cyber attacks and adopt a proactive, forward-thinking approach to cybersecurity. Cybersecurity strategies should evolve with technological advancements and include countermeasures for emerging threats like generative AI. Organizations should foster a culture of continuous learning and adaptability, with cybersecurity practices being routinely updated and tested. Additionally, collaboration between organizations, cybersecurity firms, and government agencies can pave the way for better defenses against AI-driven threats. Joint research and intelligence sharing can help identify and neutralize threats faster, while policy discussions can help shape regulations that promote best practices. While the potential threats posed by AI and generative AI are significant, organizations can turn the tables by harnessing these same technologies to fortify their cybersecurity. By being proactive, investing in AI-based defenses, and fostering collaboration, organizations can be prepared to tackle the evolving landscape of AI-driven cyber threats. In this demo, we'll work with GPT models. Okay, to get started, I've opened my Microsoft Edge browser, and I've navigated to chat.openai.com, which redirects me to chat.openai.com/auth/login. Now, from here, if I don't have an account, I can select Sign Up. That takes me to the Create Your Account page, where I can specify an email address. I can also log in from here if I already have an account, or I can use either Google, Microsoft account, or my Apple account to sign up. Okay, so I already have an account, and I'm signed in with my Chrome browser. So let's go over to the Chrome browser by selecting the Chrome browser icon on the taskbar. Okay, and on the first tab, I've signed into chat.openai.com. Now, there are a couple of GPT models listed. I'm not signed up to a paid account with this account, so I have access to GPT 3.5 only. But that's pretty significant. Now, at this point, it's important to maybe discuss a couple of options on how to interact with ChatGPT. So there are several techniques for crafting effective prompts. Common techniques include defining the output format, providing context or examples, and asking the AI to think in step-by-step or to debate the pros and cons of some subject. So in the Send a Message field, I'll type, "Debate the pros and cons of the fusion of generative AI and cybersecurity." To send the message, I can either press enter or I can select the send icon. So I'll just press enter. Then now ChatGPT is generating the response based on my request. Okay, so that's how ChatGPT works in the chat web-based application. On my second tab, so let's go over to the second tab, I'm open to platform.openai.com. Now here, I'm also signed in with the same account, and I have access to the full slate of documentation here. So if I select the documentation tab, I have all the documentation for the OpenAI platform. I also have an examples tab where there are numerous examples to play with. I also have a playground tab where I can experiment with the platform. Let's select the API reference tab. So this is the full API reference. And this is the other way that I'm going to be working with the GPT models. I'm going to be writing some Python code later in this path. So I'll need to install the OpenAI bindings. And to do that, I'll use the Python pip package manager and use pip install OpenAI to install the OpenAI bindings. Now, I'll scroll down and under authentication, I'll select the API keys link. Okay, and that brings me over to the API keys page. Now it shows that I have an API key, but if I want to create a new one, I just select create a new secret key. I can give it a meaningful name. I'll just leave the default for my demo, and then select create secret key. That provides me with the secret key. Now I can copy that and save it somewhere secure. And when I'm finished, I can select done. Now from here, if you want to revoke a secret key, you just select the trash can icon beside the secret key that you want to remove, select revoke key, and the key is revoked and will no longer be usable. Okay, so now over in the left navigation menu, I'll select usage. And this is the usage page describing my daily usage over the past month. Now if I scroll down, there's a free trial usage section which provides me with a summary of my free trial usage. Now with brand new accounts, you do get some free trial usage. Language models read and write text in chunks called tokens, and the use of the API is based on tokens. You do get some free tokens with a brand new account. Now with my account, my trial period is over. So if I want to use the OpenAI API, I need to set up a paid account by selecting Set up a paid account. Now from here, I select Start Payment Plan. I can specify my payment details, then my usage billing starts. Okay, so essentially in this path, I'm going to be either working with ChatGPT, the web-based application, or I'll be using the OpenAI API to work with the GPT models directly. With that, we've explored some ways that we can work with GPT models. In this demo, we'll perform a simple ethical hacking exercise by leveraging generative AI and the OpenAI API to analyze threat intelligence. All right, I'm on my Windows 11 research machine. Now I've got Visual Studio Code open with a Python script named threat-intelligence-summary open. This code is a Python script that interacts with the OpenAI API to generate text using the GPT 3.5 model. It defines a function called analyzeInfo that takes raw data as input and returns a response generated by the GPT 3.5 model. Okay, so let's explore the code. Starting on line 3, I import the OpenAI Python module. Now, as the comment on line 1 states, in order to do this, first you need to install the bindings with pip install OpenAI. So I'll press Control backtick to open a terminal below the code, and down in terminal, I would type pip install OpenAI, and that would install the OpenAI bindings. Now, I'm not going to do that because I've already done that. So let's go on with the code. Okay, so line 6, I specify my API key, and then on line 9, I define a variable named dark web posts, which contains a number of dark web posts that our security team was able to scrape from the dark web. Scrolling down, okay, on line 30, essentially I'm creating the raw data by joining each of those individual entries from the dark web posts. And then, starting on line 33, this is where we're really doing the heavy lifting. So on line 33, the analyzeInfo function is being defined. It takes a single parameter, data, which represents the raw data passed to it in the call to the function later in this Python script. Now, lines 34 through 38, we create the engineered prompt. We do this by concatenating several lines of text, including on 38, where the string is formatted to include the data passed in to the analyze info function. Okay, now, starting on line 40. Line 40 is where the OpenAI API call is made using the OpenAI.completion.create method. This method creates a completion task which generates text based on the provided parameters. And what are those parameters? Line 41, the engine parameter specifies the engine to use for text generation. In this case, the engine named text-davinci-002 is being used. This engine is a variant of the GPT 3.5 model optimized for generating text. Line 42, the prompt parameter, is where we provide the input text or prompt for the text generation. It's set to the value of the engineered prompt string variable. On line 43, the max tokens parameter determines the maximum length of the generated text. In this case, it's set to 250 tokens, which helps to limit the length of the response. On line 44, the end parameter specifies how many different completions to generate. Here it's set to 1, so only one response will be generated. On line 45, the stop parameter can be used to specify a list of tokens that, if generated, will signal the model to stop generating text. If set to none, like it is here, the model will continue generating text until it reaches the max tokens limit. On line 46, the temperature parameter controls the randomness of the generated text. A higher value, for example 0.8, makes the output more random, while a lower value, like 0.2, makes it more deterministic. Here it's set to 0.8, meaning the output will be relatively random. Now, on line 48, after making the API call and receiving a response, this line extracts the generated text from the response object. The response choices list contains the generated completions, and response.choices0.text gets the text of the first and only, in our case, choice. The extracted generated text is stripped of leading and trailing white spaces using the strip method, and then on line 49, it's returned as the output of the analyze info function. Okay, and on line 51, this is where we make the call to the analyze info function and pass raw data. And then on lines 53 and 54, we simply print the analysis. Okay, so down in terminal, let's run the code. And to do that, I'll type Python and the name threatintelligencesummary.py. And I'll use the tab key to autocomplete and press enter. Okay, so interesting. It returns a summary of posts that we found on the dark web. It tells us that there's a security flaw in Broken Arrow software, that there's a zero-day exploit, that there's an APT versus critical infrastructure. So I'm going to up arrow to bring the command back, and I'm going to run the same command and see if we get something different. Okay, and we get something a little bit different. This time it actually references a CVE number which was referenced in the dark web posts. And if we keep up arrowing and run a threat intelligence summary, because we set the temperature to 0.8, we should get something a little bit different even. And we do. This time it's in the form of a paragraph. With that, we've performed a simple hacking exercise by using generative AI and the OpenAI API to summarize some threat intelligence. In this demo, we'll use generative AI technologies to identify potential attacks. All right, to get started, I'm on my Windows 11 research machine. I've opened my browser and navigated to github.com/frogger, and the O is a 0, /IAtelligence. IAtelligence is a Python script that extracts the import address table from a portable executable and uses OpenAI's GPT-3 model to provide details about each Windows API imported by the file. The script also searches for related MITRE attack techniques and explains how the API could potentially be used by attackers. It also displays the file hashes and provides an estimate of the cost of the GPT-3 requests. The authors note that IAtelligence is their proof of concept for using GPT-3 for malware analysis and for quickly assessing the behavior of a malware based on its import address table. We're going to clone this repo. So I'll select the code dropdown. I'll select the copy icon beside the repo URL. Now down on the taskbar, I'll select the Visual Studio Code icon to bring up Visual Studio Code. Now in Visual Studio Code, I have a text file open, and this text file contains the information that we'll need in order to set up an OpenAI API key environment variable. But first, down in Terminal, let's clone the repo. So I'll type git clone, and I'll paste the GitHub repo URL in and press enter. Okay, so now the repo has been cloned onto my local machine. So over in Visual Studio Code Explorer, I'll expand the new Aaccess directory that was created when we cloned the repo, and I'll double click to open aaccess.py script. One of the other things that we'll need to do is install the requirements. And the requirements are listed in the requirements.txt file. So all we'll need to do is go down in Terminal and type pip install -r requirements.txt. Now keep in mind that I'm in the /demo directory, and that requirements file is in a subdirectory Aaccess. So let's go ahead and do that then. So I'll type pip install -r /Aaccess /requirements.txt. I'm using tab to autocomplete, and I'll press enter. Now I'll clear the terminal, and now with the IAT script open in Visual Studio Code, you should always keep your environment variables private and never hard code sensitive information directly into your code. So what we'll do is we'll need to alter this script. First, we'll import the OS module. So in the script on line 14, at the end of the line, I'll place my cursor and press enter, and then I'll type import OS. Now we'll need to also modify line 20. I'll highlight the double quotes, and now I'll type os.environ, and in square brackets and within double quotes in all caps, OpenAI _API _key. And that should be good. So I'll press Control S to save the file. And so now let's go back over to the text file, OpenAI _API-key.txt. And essentially what we're going to do is we're going to set up an environment variable with my specific OpenAI API key. So I'll highlight line 6, Control C to copy. Down in Terminal, I'll right click to paste the command in and press enter. Now if I want to confirm that the environment variable was actually created, I'll highlight the getChildItem command on line 9, and I'll copy it with Control C. Now down in Terminal, I'll right click to paste the command and press enter. Okay, and the results show that indeed I have set up the environment variable OpenAI _API _key. So we should be good to go. First I'll clear. And now one more quick look at the Python script. Okay, scrolling down to line 74, this is where the script defines the request _OpenAI function, and it's expecting the IAT to be passed in. Now scrolling down on line 97, this is the prompt, and it's a formatted string that includes the DLL name and the import name. Then on line 98, this is the call to the OpenAI API using the OpenAI.completion.create method. Recall that this method creates a completion task which generates text based on the provided parameters. And speaking of the parameters, let's quickly review the parameters. So on line 99, it's using the text-DaVinci-003 engine. If you're wondering what the main difference is between 002 and 003, it's that 003 has been trained on a larger data set, so it should be able to generate more accurate results. 003 can also understand natural language instructions and produce more detailed responses. Okay, now max tokens is set to 2500. On line 101, top P stands for top probability and controls the diversity of the generated text. Frequency penalty on line 102 is used to influence the model's likelihood of generating less common words or phrases. Line 103, presence _penalty encourages or discourages the model from including specific tokens provided in the prompt in the generated output. Line 104, of course, is the prompt to send to the language model, and On line 105, we have the temperature, and since this one is set to 0.6, it's going to be relatively diverse and creative. Okay, so now let's run the script, and we'll reference a portable executable that I have in my demo directory, which is supposed to be the Visual Studio Code setup binary. So now, down in terminal, I'll type python./iaintelligence/iaintelligence.py. I'm using the tab key to autocomplete, and I need to reference the portable executable .portable_executable.exe, and I'll press enter. Okay, so now the script runs. It gives us the file hashes and provides an estimated cost of the requests. And at this point, it looks like it's going to cost around 29 cents to do this analysis. So just imagine, as ethical hackers, we can go to our organization and demonstrate that, look, we can check this potentially malicious portable executable and determine whether it is actually a malicious file for 30 cents. All right, now this can take upwards of 4 or 5 minutes, and I'll fast forward through this so that we can see how the output appears. The script completes and the report is generated. It provides details about each Windows API imported by the file and explains how the API could potentially be used by attackers. All right then. Well, with that, we've used generative AI technologies to identify potential attacks. So in this course, we've examined the convergence of ethical hacking and generative AI technologies. We did this by exploring generative AI and prompt engineering concepts, the importance of ethical hacking, and the impact of generative AI on ethical hacking. We also explored generative AI applied to the hacking phases in ethical hacking, generative AI risks, benefits, ethical considerations and legality, and the role of the ethical hacker. We explored the importance of high ethical standards, preparing for generative AI in attacks, and we worked with ChatGPT. We performed a brief ethical hacking exercise, and we identified potential vulnerabilities. In our next course, we'll move on to explore the intricate interplay between generative AI and reconnaissance techniques in ethical hacking.